So in the previous class we did scalar vector, we did distance, we did what is distance. Can you see the screen? And we did displacement. So there is one proper difference between distance and displacement. So distance is the total length, total path length. So let's say your house is somewhere here and you're trying to go to the market, and since we live in a hilly area, so the roads are never straight. So there's a U-turn like this, again another U-turn, then you come to the market, right? So now this entire thing is the distance. So this will be the distance. So when you consider the curves and all these things, that will be the distance. Now displacement is the shortest distance between the 2 points. So what will be the shortest distance between your house and the market?
Straight line.
Yes, exactly. So this straight line is the displacement. Okay, so distance and displacement could difference. So this is the book difference that you should know. Book will expect you to know this. That distance is actually the total path length. It'll include all the curves, all the ascents, all the descents, whatever you do, right? Udagoy doesn't matter. So you have to consider everything. And displacement is nothing but the shortest distance, the straight line between the 2 points. So that is displacement. So this is what the book wants you to know. And I want you to know one more thing, that is distance is a scalar quantity. So you don't consider direction when you're talking about distance. So you don't say you need to go this direction to east or this direction to west. No, the distance between your house and your market is the road distance, road length. So that is 2 kilometers. So it is 2 kilometers. No one tells you about 2 kilometers southwest or southeast. So you don't find milestones when you're on a road trip to somewhere. So you find milestones, right, on the road, like Gangtok 20 kilometers, Ranipul 20 kilometers, whatever it is. So you don't find any milestones saying Gangtok 20 kilometers to the west. So it doesn't give you direction at all. So that represents the distance between your point and Gangtok at that particular moment. It's 20 kilometers. It doesn't matter, it's east, west, it doesn't matter which direction it is. It is 20 kilometers from your place if you go along the road, right? And the road will be full of twists and turns. You'll not have a straight road connecting your place and Gangtok. We don't live in a plain area. Even in plain area, a distance of 20 kilometers will not always be a straight line, right? There will be some minor turns, minor curves and all those things, right? So distance is the total path length, including all the curves, all the ascents, all the descents, whatever you consider it, right? And displacement is always the shortest distance between the 2 points. And distance is always a scalar quantity. It will not give an idea about the direction. All right, the distance will not give you direction idea about the direction, while the displacement does. So the displacement, if the distance in this case is 2 kilometers, the displacement is 1 kilometer to the, what is this? This is north, this is south, this is east, this is west, towards this is southeast. So market is 1 kilometer southeast to my house. So now you're not considering the road, because the road is not facing southeast entirely. So at this moment the road is facing southeast. Now it is not facing southeast, it's facing northeast, right? Now it's facing almost directly to south. So that when I say the market is 1 kilometer southeast of me, which means I am considering the displacement of the, we are considering the displacement and not the distance. So we are not considering the path length. Okay, so distance is a scalar quantity, displacement is the vector quantity, and this will bring about a major difference between two similar quantities, speed and velocity. So speed is basically distance upon time, and velocity is displacement upon time. So now, since distance is a scalar quantity, speed is automatically a scalar quantity. Since displacement is a vector quantity, velocity is automatically a vector quantity. Okay, so the velocity is how much displacement have you covered in a particular time. What is your displacement in a particular time limit? In 5 seconds, what is your displacement? Speed is in 5 seconds, what is the distance, right? So how much total path you walked, including all the curves, twists and turns, everything. So that is basically speed. And velocity is nothing but the displacement by time, right? So you should be very, very clear about this, right? So is this clear? So if I tell you that you are driving in a car, you're in the driver's seat, and your speedometer, right? So you have a speedometer in front of you. So there is a big speedometer here. Here it is 220 kilometers per hour. So this is in kilometer per hour. Here is 20. Here we have 40. Here we have 50. Then we have 70. Let's say then we have 110, 120. So if your dial is facing, it's like directly over 50 kilometer per hour, right? And you're driving the car and your dial is at 50 kilometer per hour. Now, will this 50 be speed or velocity? Tell me that.
Speed.
Exactly, perfect. So this is the speed. This is the speed at which your car is moving. So you will not consider velocity here because your car is not always going in a straight path. So your car is turning, twists and turns, up and turns. If you don't turn in the particular turn, you may go down the cliff, right? And you may die. So that is a possibility. So that is the reason why we consider this speedometer value to be the speed value and not the velocity value, because we are considering all the twists and turns. We are slowing down in turns. We are speeding up in straight lines, straight paths, straight roads. We are slowing down in curves, U-turns, right? So that is basically speed, not displacement. I mean velocity. It is always speed. So whatever you read in a speedometer in the car is always speed and not velocity. Yeah. So this is done. So we covered speed, we covered distance, we covered displacement, we covered what is a scalar quantity, we covered what is a vector quantity. Now we are almost at the end of the first part of this chapter, and the end is one of the most important topics, that is acceleration and retardation. Okay, so if I give you a proper, I don't give you a context, okay, I'll not give you a context, I'll just say that you are accelerating. So what do you understand if you get some idea, if something is striking you right now? What is accelerating? You are accelerating. What does that mean? What? Exactly. So exactly, you are speeding up. Correct. So accelerating is you are speeding up, which means if you are initially moving at, let's say, 40 kilometer per hour, so this is your velocity at, let's say, 1 hour ago, right? So if you are accelerating, so what should be your speed after 1 hour? Should it be greater than 40 or less than 40? 50 kilometer per hour. So now you are accelerating, right? Now acceleration is defined as the change in velocity or speed divided by time. So how much is your change in your velocity over time? So in this, the total time between your 40 kilometer and 50 kilometer change is 1 hour. And what is your speed value change? So you are changing from from 40 to 50. So acceleration is denoted by A. A is basically V2 minus V1 divided by total time. So V2 is the velocity after you speed up. After you speed up, what is your velocity? And V1 is the velocity before you speed up. So this is 40. So acceleration is 50 minus 40 divided by total time is 1 hour. So it took 1 hour for you to change from 40 to 50. So your acceleration is 10 units. So I'll not tell you the unit of acceleration right now. So this value will give you an idea about, in a particular time, how much did your speed increase. So in this case, in 1 hour, my speed increased by 10 km per hour, right? Because I was moving at 40 km per hour, my speed changed to 50 km per hour. So in 1 hour, my speed or velocity changed by 10 unit. It changed by 10 km per hour, meter per second, whatever it is. So this basically gives you idea about how much was your increase in the velocity or speed at which you were moving, right? Now retardation is just the opposite of acceleration. So if you are slowing down, that is retardation. So it has the same exact formula, but the value of A will be in negative, because if you are retarding, if you are moving at 50 km per hour, what will be your speed after 1 hour? If you are retarding, will it be greater than 50, less than 50, or equal to 50? So if you are moving at 50 km per hour, and after 1 hour it is said that you are retarding, so your speed is decreasing. So will your speed be 50, less than 50, or equal to 50, or greater than 50? Less than 50. So let's say my speed became 40 kilometer per hour in 1 hour. So now my retardation is same formula, v2 minus v1 divided by total time. So what is v2 in this case? Final velocity. What is your final velocity? Correct. So v2 is 40. So v2 is basically final velocity, and v1 is initial velocity. So what is your initial velocity? 50 divided, what is your time? 1. So what is 40 minus 50?
10.
50 minus 40 is 10. 50 minus 40 is 10. What is 40 minus 50? Minus 10. Correct. Minus 10 divided by 1 is 1. So minus 10 minus 10 unit, whatever it is. I haven't told you about this unit. So now this value tells, this negative value indicates there is retardation. So your velocity is decreasing over time. Your velocity is becoming less and less over time. So, and this value will give you by how much? By how much in unit time, let's say 1 hour or 1 second, whatever it is. In this case, we have 1 hour. So in 1 hour, your velocity decreased by 10, which means if you are moving at, if you were initially moving at 120, what would be your velocity after 1 hour?
120, accelerating.
You are retarding at this rate.
In 1 hour?
Yeah, in 1 hour.
Lesser than 120.
What would be the exact value if my retardation is minus 10?
110.
Exactly 110, right? So now if you are moving at 120 and you are accelerating at this unit at this rate, so what will be your value? I'm moving at 120 and I'm accelerating at this rate, this one. 130, perfect. So is this acceleration and retardation clear? So acceleration is by how much you are speeding up. Kati speed बढ्दैछ तिम्रो at with respect to a particular time, let's say 1 hour or 1 second. It depends on what is your unit, at what is your basic representation of speed. So if you are representing a speed in kilometers per hour, so at what speed are you moving with respect to 1 hour, or meter per second, and how much meters do you cover in 1 second, right? So it depends on, and depending upon that we'll have different units for speed, velocity, distance, displacement. Okay, now this is the last topic for this chapter, and that will be SI units. So can you give me a wild guess, if you can, the unit of length? So what will be the unit of length? Unit भनेको, like if I say, what did you say? Kilometer. Okay, so kilometer is a unit of length. Correct, it is a unit of length. Perfect, correct. But now SI unit is something different. SI unit is a common system that is used worldwide. So SI unit of length is not kilometer, it is a unit. Okay, you should not be confused about this. It is a unit of length, but the SI unit is meter. Okay, so you represent length in meter. So if length is in meter, distance को के हुन्छ? Distance को SI unit? Exactly, meter. Displacement को? Exactly, meter. Now we have speed. Before that, time को, what is the SI unit of time? No, SI unit. So like you said, kilometer for length, right? So time को के, what is the unit? What did you say? No, time. How do you like look at time? So if your exam is at 9 a.m. in the morning, and you woke up at 8 a.m. So what is the time left between time for your exam to start? 1 hour. So what is the unit? Hour. Yes, hour. But it is not the SI unit again. Hour is a unit of time, but SI unit is seconds. Okay, SI unit of time is seconds. Now let's say, what is the SI unit of speed now? Speed is basically distance by time. So what is the SI unit of distance? Meter. What is the SI unit of time? Kisi? No, SI unit of time is seconds. SI unit of time is seconds. So speed का SI unit is meter per second, meter divided by second. So for velocity is displacement over time. So what is the SI unit of displacement? Meter. Time? Seconds. So for velocity as well, the unit is meter per second. Okay. Now we have acceleration. So acceleration is basically how much velocity is changing, change in velocity. This is known as delta. So it is basically used to represent change in something divided by time. So what is the SI unit of velocity? Meter per second. Meter per second. So it is meter per second divided by what is the SI unit of time? Second. So this second will come down and multiply. So SI unit of acceleration is meter per second square. So these three terms are ekdam important. Unit of length, that is SI unit is meter. Unit of time, SI unit is seconds. Unit of speed, SI unit is meter per second. Velocity is also meter per second. Acceleration is meter per second square. Okay. So is there any doubt regarding any topic? No doubt? Okay, so this is the end of the first part of this chapter. So tomorrow we'll continue with the graphical methods of representation of all these. So from tomorrow we'll understand all these things in terms of graphs. Okay, we'll understand in terms of graphs, x-axis, y-axis, and all those things. So I'll start that tomorrow. So this is the end of today's class.